Hi there everyone, my name is Afan, and today I'm going to talk a little bit about linear inequalities. Again, today's going to be a really introductory video into linear inequalities, but now that I think of it, it doesn't really have to be introductory because linear inequalities, once you see what they are, it's really not that different from equalities. And you might be like, what's an equality? What's an inequality? Well, let's go ahead and take a look at that right now. Alright, so if I am correct in judging, you guys probably have done stuff like this in grade 7 or 8. This right here, right, is a basic algebraic equality. Alright, so what that means is that a number times 2 plus 17 is equal to 19, right? So if you were to solve this, you would bring the 17 onto the other side, 19 minus 17, and then you would have 2x equals 2, and then x equals 1. Right? So this right here is called an equality, or an algebraic equation that you solve for x, or we like to call it an equality because of this sign right here. You see that sign right there? That's an equal sign. So it's no surprise that this kind of is called an equality. Alright, so x equals 1, so if x is equal to 1, then this side is equal to this side. So that way you can call it an equality. So you might be wondering then, well, what's a linear inequality? Well, a linear inequality is basically the same thing, but remember that equal sign we had in an equality? Well, that doesn't exist anymore. Now we will have greater than, less than, or greater than or equal to, less than or equal to signs instead. What those signs are basically these signs right here. This you know is less than, this you know is less than or equal to with the equal sign there. This you know is greater than, this is greater than that, and this you know as greater than or equal to, right? Because that little sign right there just means greater than or equal to. So basically, instead of having equal signs, what we have are these signs right over here. And this is what the definition of an inequality is. We don't have an equal sign, we have these signs over here. So if you want to think intuitively about an inequality, you would think of it as these signs instead. Alright, now that we know that, let's do our first linear inequality, and guess what? I'm going to use the same example that we just did. So 2x, so 2 times a number, plus 17, but I'm going to put in a sign. 2x plus 17 is greater than 19. So what can x be? So before we go ahead and do our algebra and go all crazy with it, let's take a look at what this is saying, alright? This is saying that some number times 2 plus 17 is greater than 19. So what we're trying to find is what values of x can I plug in, and what values of x could I plug in that would allow this inequality to be true, that would allow this side to be greater than this side. That's what I'm doing. I'm going to try and look for the numbers for x which I can plug in that will make this side greater than this side. That's my purpose. That's what an inequality does. So you might ask, well, how do I solve a linear inequality? And this is the fun part. It's literally the same as an equality, but there's a slight change which I will get to after this example. So just as I said, you solve it literally the same way. So I'm going to isolate x. So 2x remains, and in the middle I have this greater than sign. So the 17 I bring onto the other side, 19 minus 17, and then you have 2x is greater than 2, and then x has to be greater than 1. So if I were to write this in, you know what, I'm going to leave interval notation for now. We don't have to worry about that right now. Okay? So x is greater than 1. So let's look at the answer that we really found. So what we're saying is that any number for x that's greater than 1, not equal to, greater than 1, will satisfy this inequality. So if we plugged in 2, right? 2 times 2 is 4. 4 plus 17, well, that's 21. So 21 is greater than 19. So we know that we've done this inequality correctly, because any number greater than 1, if we plugged in 3, 2 times 3 is 6, 6 plus 17 is 23, 23 is greater than 19. That's the purpose of an inequality. We found all the numbers that will satisfy this inequality. So any number greater than 1, not equal to, not including 1, any number greater than 1 would basically set this inequality in motion. Alright, let's do a couple more examples. Now I'm going to get to the point where things get a little bit more, the only different part about an inequality to an equality. So I had a question right here, I believe, that proved this. Okay, so let's say you had negative 3x plus 5 is is less than or equal to, is it negative 12 or was it 12? Okay, it's 12. Right, sorry, I just had a question in front of me. That was a good example that I wanted to show. Alright, so negative 3x plus 5 is less than or equal to 12. So what numbers would satisfy this inequality? Again, if you want to take a step back, let's read what this is saying. This is saying that x multiplied by negative 3 plus 5, so whatever I get there here, is either equal to or less than less than 12. So it has to be either equal to 12 or less than 12. So what numbers for x would satisfy this inequality? So again, we would solve it just as a normal equality, just I'll show you what happens, what is the difference. So basically you would say that, hey, let's bring the 5 onto the other side, and you would be correct when you say that, and that would make this 7, right? 12 minus 5 is 7. Actually, you know what, I'll show the extra step, just to help you guys out. So 12 minus 5, right? I brought the 5 to this side, so negative 3x is greater than or equal to 7 right now. So what we're going to do now, and if you know normal algebra, you're going to say, well, let's divide both sides by negative 3. Exactly, but something's going to happen to this sign, alright? Something's going to happen, watch. When I divide both sides by negative 3, this sign has to switch. So this side will be negative 7 over 3, alright? But notice what happened. When I divided by a negative number, what happens is that the inequality sign switches, alright? This is the only difference. The only difference between an equality and an inequality is when you divide by, when dividing by negative number, sign changes. Alright, so I divided by negative 3, right, to solve this inequality. Well, I had to switch the sign. So whenever you're dividing by a negative number, switch the sign. If you're dividing by a normal number, no need to switch the sign because it's a normal number. But when you're dividing by a negative number, always switch the sign. Alright, again, and then this is the answer to our equality here. So x has to be equal to or greater than negative 7 over 3. Any number that is either equal to negative 7 over 3 or greater than negative 7 over 3 will fulfill this inequality here. Let's do one last example for this video. Alright, so let's do our last example for the video. There was a cut there because I accidentally dropped my marker and this entire thing fell. So I had to fix that. I'm sorry about that. Okay, so let's do this inequality, alright? So again, let's go ahead. And if you see this inequality again, it's like normal algebra, alright? So what I'm going to do is I'm going to bring the 4x to this side. So this side is going to be 4x plus x. What am I doing? Again, just normal algebra. 4x to this side, keep the sign the same. The 17 onto this side, so 17 plus 3. Again, quick reminder, nothing happens to the sign unless I'm dividing by a negative number. Did I divide by a negative number so far? Well, I don't think I did. And yes, I did not divide by any negative numbers so far. So the sign stays the same. So just treat it as an equality until or if you divide by a negative number. So let's go ahead and do this. So 5x is greater than 20, right? So if I divide both sides by 5, again, am I dividing by a negative number? Nope. So this is just going to be x greater than 4. So any value of x that's greater than 4 will satisfy this inequality. So if I plugged in 5 minus 17 is negative 12, and negative 4 times 5 is negative 20, negative 20 plus 3 is negative 17. So negative 12 is greater than negative 17, if my mental math was correct there. But anyways, this is the solution. So you just treat it as a normal equality all the way down, you solve it normally, and you only are alarmed if you're dividing by a negative number. Here I just divided by a positive number, divided by 5. So nothing happened to the sign, and this right here is my answer. And some of you that are watching that are already familiar with inequalities, you're like, well, why isn't he writing it in interval notation? I will get to that. I just haven't done a video on interval notation yet. So when I do the interval notation video, then I'll start writing this in interval notation. But the purpose of this linear inequality, the answer is still there. X is greater than 4. So basically, that was the general idea of a linear inequality. It's literally the same as algebraic equations you've been solving since grade 8, 7. It's the same as those linear algebraic problems, All that happens now is that if you divide by a negative number, well then what happens is that you just have to switch the sign. But in this case right here, we didn't have to divide by a negative number, so this was simply the inequalities solution. The example before this, we did divide by a negative number and we had to just switch the sign. That's all we had to do. So again, linear inequalities, basically the same as linear algebraic equalities, just if you're dividing by a negative number, change the sign. Okay, hopefully that video helped, and if these videos help, please do subscribe and hit the like button. It helps me to make more videos. And yes, hopefully this helped, and you guys have a great day.